In this video I'm going to be going over the tangent radius property. So that's the first property we learn about. And it says that a radius that connects with a point of tangency will always form a 90-degree angle with the tangent line. So on the left side here you can see an example of a tangent line because it intersects the circle just once here. So that would be our point of tangency. So it's saying that if we have a radius that connects to that point of tangency, so if I were to draw a radius that connects with that point of tangency, then that's guaranteed to form a 90-degree angle with this tangent line. So right there would be a 90-degree angle. It's a fairly simple property, but there are a few types of examples that you'll see where it's useful to utilize. So let's take a look at the first one here. Okay. So it says Q is a point of tangency, and identify the following. So there's a bunch of angles here that we need to figure out. So let's go ahead and look at this first one here. It says angle OQR. So let's take a look at the diagram. If I draw a line from O to Q to R, let's see what angle we're talking about. OQR. Okay, so it's the angle at Q that we're talking about. Let me just draw it with the blue here. OQR. So since we know that Q is a point of tangency, we know from the property that that's guaranteed to be a 90-degree angle. So really easy, that's just 90 degrees. Okay, how about angle PQO? So if I draw a line from P to Q to O, well, as you can see, that's again the tangent line here and the point of tangency, so it's going to be 90 degrees as well. Okay, this next one gets a little bit trickier. Angle ORQ. So if I draw a line from O to R to Q, actually I'll do that with this pink color. ORQ. So we're talking about this angle right here. Now that's definitely not 90 degrees, right? It's not where the point of tangency is. However, we do know that we already figured out that this is 90 degrees. And we can use a trick to figure out this missing angle. So let's move over to the side here. An important side note is the angles, let's try it again. The angles in a triangle will always add to 180 degrees. Guaranteed, okay? And I'm talking about the three angles. Sorry. The three angles in a triangle will always add to 180 degrees. So let's use this to our advantage back in this question here. Okay, now we have a triangle, this one right here, and we know two of the three angles already. One's 47, one's 90. So we can figure out what the missing angle is because they need to add up to 180. One's 47 and one is 90. So let's write this out. We've got a 47-degree angle, we've got a 90-degree angle, and we're missing the last one. So that's what we need to figure out. So I'm just going to write plus blank. But we do know that when they add together, we get 180 degrees. So to figure out the missing angle, we just need to subtract both of these numbers from the other side of the equation. So I'm going to do 180 minus 47 minus 90. Okay, I know 180 minus 90 is 90, and 90 minus 47 would be 43. So 43 degrees would be our answer. Okay, last one, angle QOP. So I'm going to draw a line from Q to O to P. Alright, this is our missing angle here. Okay, we're trying to figure out this angle. Now again, we can use the same principle we just used, where the three angles in a triangle add up to 180. We know this angle is 90, we know this one's 51, and we know the three of them have to add to 180. Let me just move over here. Okay, so we've got a 90-degree angle, we've got a 51-degree angle, that's the one right there, and we have our missing angle. And they need to add up to 180 degrees. Okay, so we're going to use the same process. We're going to subtract 90 and 51 from 180. And if you do that, you would get 39 degrees. So that angle right there is 39 degrees. So yeah, that's a really important technique to remember. Basically, if you're ever given two angles in a triangle and you're trying to find the third one, you know you can always use that strategy. Okay, so let's take a look at another type of example down here. Oh, sorry. Alright, so it's the exact same diagram. And it says if the line QR, so the line from Q to R, is 10 centimeters, and the line OR is 12 centimeters, what is the length of the radius? So the first thing I'm going to do is I'm going to label these distances on my diagram. Okay, so the line QR is up here, and that distance is 10 centimeters. And the line from O to R, that's this one here, is 12 centimeters. And what we're trying to find is the length of the radius. So that would be this last line here. Now you'll notice that we have a right angled triangle, which is great because that means we can use the Pythagorean theorem to find the missing side length. Hopefully you remember to do that. If not, here's a quick recap. Whoa, what the heck? Why did that? Oh, okay. So the trick to doing this, the first important step is to label the triangle with your sides A, B, and C. Remember that C is the length of your hypotenuse, and that's the longest side, and it's always opposite the right angle. So here, if this is my right angle, opposite is down here. So 12 is my C, and then A and B could be the other two sides. So we're looking for one of the shorter sides. That's the important thing to notice. Okay, so our first step is to square both of the side lengths that we know. So we've got 12, and if I square that, that is the same thing as 12 times 12, which is 144. Next, I'm going to square the other number. 10 squared is just 10 times 10, so that's 100. Okay. Next step is to either add or subtract those two numbers. Remember, if we were looking for a bigger number, the longer side, we would add them. But since we're looking for one of the shorter sides, we're going to subtract these numbers. So the bigger number minus the smaller one. So I'm going to do 144 minus 100, and that gets me 44. And then the last step in the Pythagorean theorem is to square root that number. So if I calculate the square root of 44, just using a calculator, I get about 6.6. So centimeters, don't forget your units. So 6.6 centimeters would be our radius of this circle. So that's it for this video. So another important thing to notice with this example is anytime you're trying to find the distance of something related to this unit, chances are pretty good you're going to have to use the Pythagorean theorem. So keep that in mind.